Welcome in online tutorials, and this is electronics. Is the Form 4 course. The name of the course is electronics. So electronics. To know electronics, consider many times you have seen in the shops, in the electronics shops. Katika muda mwingi umeweza kuona katika maduka ya electronics, kuna maduka yameandikwa electronics shops. So utaona kule kuna vifaa vinauzwa, let's say TV, radios, fans, utaona vitu kama hivyo. So those are the electronics subsystems. Those are the electronics systems. So in electronics, ili kujua electronics, consider the image like this. Where have you seen this image? Where have you seen? Picha hii umeionea wapi? So picha kama hizi inawezekana tukawa tumeziona katika TV, katika radios na katika electronics component tofauti. So also this is a complex system which is made by the components like this. We have the resistors, we have the capacitors, we have the diodes, we have the inductor. So those components are made this a complex system, are used to make this complex system. So if you observe, you will find those capacitors, diodes, inductor into that system. So what is electronics by actual definition? So in order to know the electronics, the word electronics is consists the prefix IC, ICS, IC and S, which means is start off. So it is start off. So the electronics is start off, but also consists the word electron. The word electron. So electronics means deals with the study of electron, but in the study of electrons, we have the formal definition of electronics. Electronics is the branch of physics, so it is a physics branch which deals with the study of emission. The first is emission, behavior, and effects of electrons So when we talk about the emission, consider, let's say we have the metal which consists of electrons. So if electrons is knocked out of the metal surface, so this is we call emission. This is called emission. So those are the emission of electrons. So also the behavior of electrons, we'll discuss about the behavior of electrons, also in effects of electrons. So another thing, we have the electronics component and the electronic systems. So as we see that the electronics component consists those above components consist the diodes, the resistors. These components are electronic components. So these components are joined together to form the electronic system. Electronic system. So another thing to know is types of materials that are used to make the electronic components. So you have the three types of materials used to make electronic components. These are three types of materials. So the first one is insulator, we have the semiconductor, and we have the conductors. So without wasting the time, so the first is insulator. So if we need to know about the insulator, consider this is insulator material. Let's say this is insulator material. So if we have the current, electric current passing through, if meets with the insulator, the electric does not penetrate. Do not penetrate. So insulator are those materials which do not allow the passage of electric current through them. So are those materials which do not allow the passage of electric current through them. So these are the insulators. So by formal definition, we may say that insulator are those materials or substances which do not allow the electric current to flow through them. So those are the insulators. So the example for insulators, we may have the mica. So this is the mica. We have the mica. See the image. We have the wood. So this is wood. We have the wood. Insulators do not allow the passage of electricity. Another thing that is other example for insulators. So we have the another definition which explain us very good for more knowledge. We may say that electrical insulator is a material whose internal electric charges do not flow freely and therefore make it impossible to conduct electric current under the influence of electric field. So under the influence of electric field, example of the insulator. So example, this is insulator material, and we apply the potential difference. So we have the positive, we have the negative, like a battery. So we assure that the current will flow through this because you have the positive potential and negative potential. But for insulator, no current flow, no current flow. So why the insulator does not conduct electricity? Because it have no mobile charges, no mobile charges. Hakuna charge ambazo zipo huru ambazo zinaweza zikamove, the mobile charges. So these are the insulators. So this construct with other materials. So this property is different with other materials like semiconductors, like conductors, which conduct electric current more easily. So the conductors and semiconductors conduct the electric current. The property distinguishes that an insulator is its resistivity. So it is resistivity law, the resistivity law. So tabia hii ambayo inatofautisha insulator na material kama semiconductors na conductors ni resistivity yake, ni ile ability ya hizo insulator kuresist umeme kupita. So the insulator have high resistivity than semiconductor. Insulators having high resistivity than semiconductors or conductors. Kwa hiyo ule uwezo wake wa kuzuia umeme kupita ambao tunauita resistivity, insulator uwezo huo ni mkubwa sana kuliko katika semiconductor na conductors. So insulator may conduct electricity when sufficiently large potential difference is applied. So when the high potential difference is applied, the insulator may conduct electricity that the electric field knock electrons away from the atoms. This is known as the breakdown voltage of insulator. So sometimes when we apply, for example, of this example, we apply the high potential, and this is low. So we have the high potential difference. So the electrons may be knocked. So electrons may start to move for the insulator if we apply the high potential difference, high PD. So tukiapply potential difference ikiwa kubwa, inawezekana insulator is conduct electricity. So na hiyo potential difference itajulikana kama inaitwa breakdown voltage of insulator. So example for insulators is we say glass, previously tulisema papers, and Teflon, which have high resistivity. They have high resistivity. Insulators are employed as insulation for electrical wiring. Kwa hiyo insulators zinatumika kufanya insulation ya electrical wiring, kuzifanya zile wiring wire ambazo za umeme zisiweze kuconduct electricity kwa nje. Tunaona kwa mfano waya hizi hapa. tunaona kwamba these are the wires and this is insulators. Insulator. Hata majumbani tunaona nyaya nje zina insulation. Kwa hiyo hizi ni nyaya ambazo ni conductors, zina conduct electricity, lakini nje huku kuna insulator ambazo ziconduct electricity. So these are the insulators. So this is example for insulator and their uses. So another material is conductors. Another material is conductor. So conductor are those materials which allow the passage of electric current through them. So for example, we have this material. This is conductor. And when the current passing through and meets the conductor, the current penetrate. So this is conductor, and this is electric current I. So the electric current I passing through the conductor. So those material allow the passage of electric current is called the conductor. So you have the formal definition. So the formal definition, you may say that the conductor is the type of material that allows the flow of electrical current in one or more directions. So the flow will be in one direction or more direction. For example, a wire is an electrical conductor that carry electricity along its length. So in metals such as copper, aluminium, the movable charge particles are electrons. So the charge carriers in metals, vibebaji vya charge katika metals ni electrons. Positive charges may also be mobile. Positive charge inawezekana nao zikawa mobile, zikawa zina move, such as cationic electrolytes. Kwa hiyo kumbuka knowledge ya electrolysis katika chemistry, tunaona kwamba cation nazo zina move zile charge ambazo ni positive. Kwa hiyo inawezekana zikawa zinabeba umeme. So another thing to know is about the semiconductors. And semiconductor are materials that have electrical conductivity value falling between that of conductor and the insulator. So electrical value falling between the conductor and the insulator. So for example, this is electrical conductivity sigma. Let's say electrical conductivity sigma. So we may see that the conductor, we have the conductor, let's say conductor, we have the semiconductor, and we have the insulator. So we may see that the electrical conductivity increases in this way. So the insulator having low, the semiconductor having the intermediate, and the conductor having the high. So this is direction of electrical conductivity. The symbol is sigma. For electrical conductivity. So those are the semiconductors. The electrical conductivity is in between the conductor and the insulator. Kwa hiyo electrical conductivity ya semiconductor ipo katikati ya insulator na conductors. Semiconductor are the foundation of modern electronics. Semiconducting materials exist in two types. So you have the elemental materials and we have the compound materials. So elemental is single element, and the compound is a compound. Kwa hiyo hizi semiconductor inawezekana zipata kama element moja au compound ambayo ina elementi nyingi tofauti. But we have the conductivity of conductors, especially metal, decreases with increase in temperature. So at this we see the effect of temperature in those electronic components materials. So effect of temperature. So in metals, the conductivity of conductors, especially metals, decreases with increase in temperature. So for example, this is temperature increase, the electrical conductivity decreases. So this is increasing of temperature and this is decreasing of electrical conductivity. This is for metals. So what is the effect behind the thermal energy? Causes atoms in metals to vibrate and excite atoms interact with the scatter electrons. So for example, kwa nini inatokea hivyo kwamba katika metal temperature ikiongezeka electrical conductivity inapungua? For example, tuna metal, hii ni metal yetu, ina free electrons, let's say the copper pair. Tuna electrons, free electrons, lakini katika metal tuna atoms. Kwa hizi electrons zinakuwa zinapita, zina pass through. Kwa hiyo umeme ndio unabii transferred hapo, electrons zikiwa zina move. So kama electrons zikiwa zina move ndio umeme hii ni positive, hii ni negative, ndio umeme unapita. Endapo tukaweka heat, let's say tuka-apply hapa heat, tutaona hizi atoms zitakuwa zina vibrate. Zikiwa zina vibrate zinakuwa zinazuia hizi electron kumove katika mstari wake kwa uwepesi. Kwa hiyo inapunguza mobility ya hizi electron kupita kwa uharaka. Kwa hiyo tutaona kwamba tukiongeza joto hizi electron zitakuwa zinagongana, hizi atoms zitakuwa zina collide na hizi electron, na pia hizi electron nazo zitakuwa zina move, badala ya kwenda mbele zitakuwa zinashuka chini kwa sababu zitakuwa zina vibrate, zinaenda chini na juu, chini na juu, chini na juu, mfumo wa crystal lattice kama hivyo. Kwa hiyo itasababisha kwamba hizi electrons zisiwe na mobility kubwa, na kama mobility haitakuwa kubwa basi umeme hautakuwa wenye kuzalishwa effectively katika metals. So they're decreasing the mean free path and hence mobility of electrons to decreases. So mobility of electrons decreases. Since the resistivity, so we know that the resistivity is given, the resistivity rho equals to 1 over sigma conductivity. The sigma is for conductivity. Since resistivity is 1 over conductivity, so if the conductivity decreases, the resistivity increases, and vice versa. So another thing, the electrical conductivity of semiconductor will increase exponentially with increase in temperature. So, but for semiconductor it's different for the conductors, which goes directly proportional with the increase in exponential form. So if the temperature increases, so this is increase in temperature. Temperature increases, the conductivity also increases exponentially. So this is for semiconductor.